So, hello and welcome students to this 30th lecture of the course chemistry. The code for this particular course is CH101 for the odd semester and CH201 for the even semester, right? This is G. Chakraborty from Department of Chemistry and you are watching the course chemistry. Now, as you already know that this is lecture number 30 and we are studying polymers. So, polymers are of different types that we people have studied in the last lecture, right? And how polymer is important to us, why polymer is important to us, that also we people have studied. Okay. Now, what we are going to do here, in the last lecture we have studied about different types of preparation of polymers like addition polymerization, condensation polymerization, okay, how they occur, right? And what are the basic conditions for their occurrence and what type of products are formed, that also we people have seen along with reactions, right? Now, in this particular lecture, we are going to see something different. Now, what is that different? Let us check it out. So, hello and welcome again. This is Polymers Part 2. And in this particular lecture, we are going to see clearly that what are copolymers, what are homopolymers. Accordingly, we are going to see what is copolymerization reaction, what is homopolymerization reaction. Along with that, we are going to see what are rubbers, what is vulcanization of rubber, and what are conducting polymers, right? So these are the main topics of this particular lecture. So let us start the lecture. Right. So as you can see, the first topic that we are having is copolymerization. Now question arises, what is copolymerization? Okay. So we will see that. Before going into that, just there is one question that I'm giving you this question for thinking. You just think about it. Okay. And at the end of this particular slide, we will discuss about the answer of this question, right? So this question is for your mind exercise. Okay, just see here it is written butadiene styrene copolymer, and my question is that what is the other name of this polymer, which is butadiene styrene polymer? What is the other name of this particular compound? That is my question. Butadiene styrene polymer has some different name also. What is that different name? That is our question. Okay. So let us see what we are having and let us start. Okay. So copolymerization is a polymerization reaction in which a mixture of more than one monomeric species is allowed to polymerize and form a copolymer. Right. Now let us have a quick recap about addition and condensation. Why I'm saying this, you will understand gradually. That in addition polymerization, we have seen what the different aspects are. We have seen that the same monomer, right? Same monomer is repeated, okay, and due to which the polymer is formed. So same monomer means only one type of monomer is allowed to react in the method which is called addition polymerization, right? Now, can you tell me that in addition polymerization, is the process of addition polymerization available for preparation of copolymers, or is it at par with copolymerization reaction? Answer is absolutely no. Why? Because the copolymerization reaction definition itself says that it is mixture of more than one monomer substances, means more than one type of monomer substances. As we can see in the diagram, that 1,3-butadiene and styrene, both are far apart, both are different, and they are combining to form butadiene styrene polymer. Again, remember about the question, what is the other name of butadiene styrene polymer? We need to find out at the end of the lecture. Okay, this is my question to you. Okay, just check it out whether you can find it or not. Okay, without any cheating, obviously. So the copolymer can be made not only by chain growth polymerization but by step growth polymerization also. So before going into this chain growth and step growth polymerization, let us we have discussed about addition polymerization. Just try to remember what was condensation polymerization. In condensation polymerization, two or more species combined together, or we can say two different type of species combined together to form one particular molecule with loss of HCl or something, right? Okay, so basically what we are seeing it is clearly written that the copolymer can be made not only by chain growth polymerization but also by step growth polymerization. What do you mean by this? It means that condensation polymerization can be used gladly to make this copolymers and to execute the process called copolymerization. Okay, now it contains multiple units of each monomer used in the same polymeric chain. For example, a mixture of butadiene and styrene can form a copolymer. Okay, so this is butadiene, this is styrene, this is their polymer, right? Now copolymers have properties quite different from homopolymers. Now we have not seen what homopolymers are. We'll see it in the next slide, I guess. Okay, for example, butadiene styrene copolymer is quite tough and is a good substitute for natural rubber. Yes, butadiene styrene copolymer is actually synthetic rubber. Okay, now do you remember what is butadiene styrene polymer? Remember, in the last lecture it was decided as example of it was declared as example of synthetic polymer. This is BuNa-S. Okay, the answer to the question was BuNa-S. Another compound is that BuNa-N, and for that the monomers are 1,3-butadiene and acetonitrile. Okay, now it is used for the manufacture of auto tires, float tiles, footwear, compounds, cable insulation, etc. So the tire of my vehicle is made up of BuNa-S. The footwear that you use may be made up of BuNa-S, basically the sole of the shoe. Okay, cable insulation also requires this type of thing. Okay, so that's how it is. Let us go to the next slide. Okay, now we are having homopolymerization. Let us check it out what we are having inside this homopolymerization. Homopolymer is defined as the polymer that has the same monomer units in the chain. Examples of homopolymers are PVC with vinyl chloride, propylene and propyl units. Polymethyl methacrylate is also an example. Okay, so big examples are there. Basically, homopolymer is, the homo means same, so same monomer unit will repeat to form a polymer, right? So this is nothing but addition polymerization process. Okay, same ethene is repeating to form polyethene, styrene is repeating to form polystyrene. Okay, like that. Now as you can see, homopolymers, for the diagram clearly implies same unit is repeating again and again and again. There is a blue unit, but here in copolymer you can see blue, pink, blue, pink, blue, pink, means two different type of things are getting added. So second one is condensation, whereas the first one is addition. That means homopolymers are formed by condensation reaction, whereas homopolymers are formed by addition reaction, whereas copolymers are formed by condensation reaction. Okay, now let us have a quick difference between homopolymers and copolymers. So homopolymers are formed through addition, copolymers are formed by condensation. Just 10 seconds ago we have discussed about it, so I'm not explaining it again. Now it consists of single species of repeating units, more than two or more type of repeating units. Yes, as it is homopolymer, so one type, and as it is copolymer, so more than one type. Okay, have single type of polymer, have multiple type of polymers, simple structure, complex structure. Example is PVC. PVC is from polyvinyl chloride, so vinyl chloride unit will be on and on and on. Polyethylene is, ethylene unit will be on and on. Polypropylene, polystyrene, propylene and styrene units will be on and on, right? They will be combined together. Whereas here we are having polyvinyl acetate, polyethylene oxide, etc. These are the examples of copolymers, right? Okay, so that's how it is. Let us go to the next slide. Okay, now we have something good. What is this good thing? This is nothing but rubber. So rubber is right here, so you will stretch it out and stretch it out, right? Okay, jokes apart, rubber is a natural polymer and possesses elastic properties. We know it very well that rubber is a natural polymer and it is quite elastic in nature, due to which it is called elastomer also. Elastic polymer or elastomer, right? In elastomeric polymers, the polymeric chains are held together by weak intermolecular forces. Why weak intermolecular forces? Because they have the property to expand. Now, expansion is possible only if elastic properties, this type of compounds are having weak intermolecular forces. Okay, these weak binding forces permit the polymer to be stretched. Fine, we have discussed A few crosslinks are introduced in between the chains which help the polymer to retract to its original position after the force is released. So yes, the attraction forces are weak, but whenever we release the pressure or we release the force, then what happens? It comes back to its initial position. Now that is possible only and only if this particular um, some sort of bonds are there, some sort of chains are there, which will carry them back to their original position, right? Rubber has a variety of uses. Okay, what are the uses? It's manufactured from rubber latex. There is latex of poppy plant, we people know. Latex of rubber plant, sorry, not poppy. Okay, it's colloidal dispersion of rubber in water. This latex is obtained from rubber tree found in India, Sri Lanka, Indonesia, Malaysia, and South America. Fine. Natural rubber is nothing but a linear polymer of isoprene. This is natural rubber. You can see isoprene units are as linear, almost linear zigzag fashion. Okay, that is 2-methyl-1,3-butadiene. Okay, so you can see this clearly, this particular isomer of isoprene, right? And is also called cis 1,4 polyisoprene. Fine. This particular molecule consists of various chains held together with weak van der Waals attraction and has a coiled structure which can be stretched like a spring, and this also exhibit elastic properties. Okay, so it is coiled structure, it can act as a spring, it can be elastrate, so it is called elastomeric polymer, right? It works just like a spring and it exhibits this type of elastic properties. Okay, this was all about rubber, but we are not ended with rubber because rubber has some more features. What these features are, we have only done natural rubber. What about synthetic rubbers? Synthetic rubber is any vulcanized rubber like polymer which is capable of getting stretched towards its length. Okay, so here the stretching property increases. As you can see, natural rubber is isoprene, synthetic rubber is neoprene, and here Cl group is introduced instead of that particular methyl group. Okay, so it can be stretched towards its length. However, it returns to the original position as soon as the strength is released. Okay, synthetic rubbers are homomers, that is 1,3-butadiene derivative or derivative of unsaturated monomer. Means synthetic rubbers are nothing but derivatives of 1,3-butadiene, means styrene or acrylonitrile, bunais or bunaine, right? That means bunais is formed by 1,3-butadiene plus styrene and bunaine is formed by 1,3-butadiene plus acrylonitrile. Okay, so this is the main thing about synthetic rubber and natural rubber, but still we are not ended with rubber because we have something more, I believe, and that more is nothing but vulcanization of rubber. Okay. Now, what is vulcanization of water? Not water, sorry. What is vulcanization of rubber and what is vulcanized rubber? Let us try to find out. So, natural rubber becomes soft at high temperature and brittle at low temperature, okay, which shows high water absorption capacity. It is soluble in non-polar solvents and is non-resistant to attack by oxidizing agents. To improve upon physical properties, a process of vulcanization is carried out. Now, what is this vulcanization? Why it is used? Because there are the natural rubber lacks some properties. Okay, so in order to have those properties, vulcanization is basically done. Now, what is vulcanization? Rubber is heated with sulfur. Okay, and as you can see in the compounds here, the sulfur atoms are incorporated inside rubber. So rubber is vulcanized and it becomes strong. Otherwise, what will happen? Rubber becomes brittle and it breaks down. Okay, that's why. So this process consists of heating a mixture of raw rubber with sulfur and appropriate additive at temperature. This on vulcanization, rubbers form crosslinks at relative sites of double bond, thus the rubber gets stiffened. In the manufacture of tire rubber, 5% sulfur is used as cross-linking agent. So basically, natural rubber is good, but it is quite brittle and it will break down. That's why, in order to increase its elastic properties, it is vulcanized. Okay, now vulcanization of rubber requires heating with one chemical, that is nothing but sulfur. So when sulfur is added to raw rubber and is heated, then what happens? We get vulcanized rubber, right? Okay. Next, what we are having? So we are having conducting polymers next. Now, what conducting polymers are, we need to know. And what are conducting polymers? Basically, there are certain polymers which are more precisely intrinsically conducting polymers. They are organic polymers and they conduct electricity, right? So as they're called conducting polymers, definitely they will conduct electricity. Such compounds may be metallic conductivity or be like semiconductors. So it may be of two types. Either it may have conductivity similar to that of metals, or it may have conductivity that is similar type of semiconductors. Okay. Biggest advantage is their processability, mainly by dispersion. Conductive polymers are generally non-thermoplastics. They are non-formable. But like insulating properties, they are organic materials. They offer high electrical conductivity but do not show same mechanical properties to other commercially available polymers. So basically what happens, they're non-thermoplastic. That means they're thermosetting polymers, number one. Number two, they do not show any insulating property, rather they show electrical conductivity, but their mechanical properties are similar to that of the other polymers. Okay, the electrical properties can be fine-tuned using the methods of organic synthesis. Yes, that we people know very well, that we can have a little bit engineering techniques, and we can change the structure of this particular polymers, and in that way we can have some modifications regarding their conductivity and all. Okay. So let us see what we are having here. What are the examples of this particular polymer? So we are having polyacetylene, polypropyrrole, polyaniline, and polyphenylene. Okay, all these four are examples of nothing but conducting polymers. So basically, as you know that when the word polymer comes to our mind, then we gradually think that okay, it is insulator, it is not a conductor. But there are certain polymers which are basically organic compounds. Every polymer is organic compound, that is quite common, right? But there are certain organic compounds which are actually polymers and which actually shows a good conducting property, right? So they're called conducting polymers. But it may happen that some of them directly show properties of conduction, while others may show properties of semiconduction. Okay, so this was all about the conducting polymers, and I guess this is the last slide of today's lecture. And what we have seen in this particular lecture, let's just sum it up. So what we have seen in the very first condition, the very first position, we have seen what are copolymers and what are homopolymers, right? And we have seen how homopolymers are formed, how copolymers are formed. Also, we have established the relation between addition and condensation polymerization along with homopolymerization and copolymerization. Okay, this relation we have established. Okay, after that we have seen what are the differences between these particular polymers. Then we have started rubber. Now, what is rubber? How it is formed? Why it is used? How it is used? Okay, what is natural rubber? That we people have seen. Where it is found? Every data we have seen. After that, we have seen what is synthetic rubber or artificial rubber, how it is formed. Okay. After that, we have seen what is vulcanization of rubber, why vulcanization of rubber is important, and why we are doing so. What happens when rubber is vulcanized? That also we people have seen. And after that, we are having the conducting polymers. I'm not telling again because we have just discussed few moments ago. Okay. So this was all about this lecture of today, where we people have found out this different type of polymers, right? And homopolymer, copolymer, conducting polymers, and we have also seen the details of rubber. In the next lecture, we are looking for some more important things. Now, what these more important things are? We've been looking for thermosetting and thermoplastic polymers. Along with that, we are having biodegradable polymers, and also we will, in the next lecture, we will discuss one by one what type of polymers are formed, how they're formed, and how they're used. Okay, so till then, thank you so much, and this is all about today's lecture. We'll meet again in the next lecture, that is part 3 of polymers, lecture number 31. Okay, so till then, you stay safe, study polymers, and be healthy, right? Thank you.